Back to Advent of Code 2017, Day 6, Memory Reallocation. The debugger program here is having an issue. It is trying to repair a memory reallocation routine, but it keeps getting stuck in an infinite loop. In this area, there are 16 memory banks. Each memory bank can hold a number of blocks. The goal of the reallocation routine is to balance the blocks between the memory banks. The reallocation routine operates in cycles. In each cycle, it finds the memory bank with the most blocks, ties one by the lowest number memory bank, and redistributes these blocks among the banks. To do this, it removes all the blocks from the selected bank, then moves to the next by index memory bank and inserts one of the blocks. It continues doing this until it runs out of blocks. If it reaches the last memory bank, it wraps around to the first one. Debugger would like to know how many redistributions can be done before blocks in banks configuration is produced that has been seen before. For example, imagine a scenario with only 4 memory banks. Start with 0, 2, 7, and 0 blocks. The third bank has the most blocks, so it is chosen for redistribution. Starting with the next bank, the fourth bank, then continues to the first and the second. 7 blocks are spread over. The fourth, first, second banks get 2 blocks each, and the third bank gets 1 back. The final result looks like this. Next, the second bank is chosen because it contains the most blocks. Because there are 4 memory banks, each one gets 1 block. Now there is a tie between the first and fourth memory banks, both of which have 3 blocks. The first bank wins the tie, and its 3 blocks are distributed evenly over the other 3 banks, leaving it with none. How do ties get handled? Ties won by the lowest numbered memory bank. Okay. First, the fourth bank is chosen, and it's 4. Okay, but only the first bank wins, and then we check again. Its 4 blocks are redistributed that each of the 4 banks receive 1. The third bank is then chosen, and so on. At this point, we've reached the state that we've seen before. Okay, so let's check this example. We can while input equals this, okay, we just want a mutable list, and then we just collect all the visited states, which is a list of int, and then, well, we can add input there. Then we do something. Then we check we get a new one. Get next. To do if next in visited, then we're done. And we're kind of in some loop or something. Why we're not done. And then we print blueprint. What's the question? How many cycles? Yeah, okay, so we count the cycles again. 0. And every time we check, so we have to check the next one. So what's the next one? Redistribute and can make a current one as well. And then we just use cur, redistribute cur. Then we can just make a function. Return the list of int. So we just go and say, get the biggest one. Give me the index of the biggest one. I can just map indexed I and it, I to it, max by it. What is sorted by the second one? Why can I not just get the max off? Okay, that's the max. Or I just get the indices and then I just get the max later. Get this and then I just do filter second is the maximum. Maximas equals this. If maximas size equals 1, then we're fine and we can just go and pick first one. Else, if it's a bigger one, then we just sort the first and just take that one. And by or null. Oh, that's super weird. I like this one more. And then I have the one that I need to redistribute this one. It has an index and a number of things. So then I go, well, C is smaller than, need to distribute. Second, I go start redistributing. And the index I distribute towards. Curve 1. First of all, I have to set curve 1 is such a bad name. Let's do result. Result of need to redistribute dot first. So the index of the first one. That one's set to 0 because I'm redistributing that part. Then, while I'm counting through the distribution, I I need to find the index that I'm currently distributing to, which is, I think, C plus size mod or it's just C modulo cur dot size. So if I had 1, I'm fine. I can just redistribute there. Let's say there's 4 elements and I have 5. Or I'm at index 4. Then I modulo that. Okay. Then I just go result of this index equals pop it out. It's 1. Return the result. Okay. I don't actually need a mutable list. Let's do this. So I'm getting 0. This maybe doesn't change anything. See what's happening here. There is 0270. Indices is 00, 1, 2, 2, 7, 3, 0. Then I get the maximum. 7. Or this is max off. Oh yeah, that's fine. And then we get the maxima, which is 2, 7, which is just one of them. So we can go first one. I need to distribute. Okay, 0, 0. Obviously, want to get maximas first and not all of them the first one. Okay. That could be the bug already, but now it's running really long. Let's check this again. And go here. We have these 2 and 7. Okay, cool. Then we go here. We go here. See a 0. Get the mutable list. Whoa. Oh yeah, we changed one that had 7 there to 0. Then we get is C smaller than 7? Yes. We increase by 1. The index is 1. Yes, we do have one more thing to offset. That is our starting index. Start again. So the first index is 0. Ah, yeah. Sorry, this is the first. First is the index. Hmm. So then index 3 is the one that I want to update. And the result has, let's go one further. Now I have 1 here. Oh, at index 0, C is 2. And so on. Let's go to the end of result. I have 2, 4, 1, 2. I think that's what we wanted. 2, 4, 1, 2. Okay. I think I can always have this. If it's just 1, I can also sort it. Although it's kind of silly to sort a list that says 1. Okay, this can be change. Replace it. And why does it not end? Okay, we never add anything to visit it. Add in there, and that should do it. 4, 4. Okay, if we start with 1, we'll start with 0, but we say we increase when we do this like this. Then we have 5. Then we get our input. This. And we get a loop after this many. And that's correct. Part 2. Out of curiosity, the debugger would also like to know the size of the loop. Starting from the state that has already been seen, how many blocks with distribution cycles must be performed before the same state is seen again? 2, 4, 1, 2 is seen again after 4 cycles, and so the answer is 4. How many cycles are in the infinite loop? Okay, so we check the next one again. I don't understand the question. we start with this. And then, okay, and then we find it once and then we find it twice. When I have the visited mm, can I just do, yeah. Print line. Oh, I just do if it last I else 0 or -1 or null. Um, address. Maybe this. Okay, so here I've obviously find something that I saw again at the end, which is this one. And then I can just print the two indices that I that have the value of the last one, this one. I just print the two indices of those two occurrences and then take the subtract each other. So that should be it. Okay, that's it for day 6. So what do? We get the input. We add the input as into our visited list. There's a list of ints. Then we make some counters. Done is false. Let cycles to 0. Every time we do a loop iteration, we go cycles +1 and redistribute, which is just finding which is the maximum in the list and which index it has. That's why I do this. I map the I to it. And I check, maybe there's multiple maxima. I just check what is the ones from this list that have this maxima. Maybe there's 2, and I sort them by the first one to break the tie and get the first. Otherwise, I just take the first, the only one in the list. That's the pair that I want to redistribute. That's the index of the pair, and that's the value of the pair. Then I do the actual redistribution. So for C smaller than value of the pair, I make a mutable list, set the value of the pointer where the one that I want to redistribute the index to 0 so that I can take all the value from there and redistribute it. And obviously do that for the amount of time that the value is of the one that I want to redistribute. So that's why I always increase by 1 here. Then I just take the index of the one that I want to redistribute and add the offset to it. At the beginning it's 1 and then 2 and 3 and so on. And if I go over the end of the list, I start at the beginning, so I can do modulo size of list. For each of those iterations, I increase at the index that I calculated here, the result set by 1, so that I always distribute 1 from this original value to each of the other fields. Then once this result list is updated, I return it. So I go back here, I redistributed it, and this is the new current list. Cycle is increased. If the current list is invisited, means I already saw it. That means we're done. We have a loop. And I add the visited to cur. I can just do this here actually. I always add the visited to cur, and then I can check the cycles, check the last. This is the part for part 1. How many cycles will it take to find the loop? Then I check the one that actually is the loop that I found twice in my set of visited. I check all of the ones, so the 2 ones that I found that have the value equal to the last, so the list is equal to the last, which is the one that I found that is looping. And I map those indexes from that list, which is 2 different ones. And then I can just take the difference between them to get part B. And that's it. Enjoy the rest of your day.